All right, we have to talk about addition, subtraction, multiplication, and division of integers. This is all stuff you know how to do. I just want to make sure we know what happens when some of those integers are negative, basically. So just a couple of, I guess, etiquette notes. We don't really use the X symbol for multiplication anymore, ever. It's outdated, and then since this is, technically an algebra course, eventually we want to use X as a letter, as X, so that would get confusing. So we use a little dot. And oftentimes you'll see it as a little asterisk instead of a little dot. That's easier to type. So like that. So don't write 3x7 equals 21. Not that I wouldn't know what you meant, but just get in the habit of not doing that if you were in the habit of doing that in the first place. And then we also don't really use numbers like 4 and 2/3 anymore. So that's called a mixed number. If we had to bust out a number like that, we would probably use a decimal. Now, there are certainly certain contexts where we could, but just for now, when we're just doing pure math, we don't want to see numbers like that. They're hard to do math with, and they're confusing to look at. Basically, because it looks like 4 times 2/3, and you know that it's not. It really means 4 plus 2/3. So use that fact to convert it to what's called an improper fraction. And remember, an improper fraction is one where the numerator is bigger than the denominator. So that's like kind of a misleading vocabulary word because I'm telling you that that's actually proper. Okay, so improper fractions are proper. Mixed numbers are now improper, technically. Okay, so you've probably seen this before, but here's how you do it. You know that 4 and 2/3 means 4 plus 2/3. So add those things together by getting a common denominator, right? So 4 is 12/3, so this is 12/3 plus 2/3, which is 14/3. And you probably remember the trick. You don't even really have to do all that. You probably remember the trick where you multiply these numbers. So you do 3 times 4, which is 12, and then you add this number. So 3 times 4 plus 2. And then you just keep the same denominator, right? So 3 times 4 is 12 plus 2 is 14, and then it's over 3. So if you did that in your head, like on a test, I wouldn't take points off. That should be something that you can do pretty quickly. Or you can write it out, right? Because this is really what you're doing when you do that trick. You are converting 4 into some, 12/3 and then adding. So now let's get into what to do with negative numbers. Adding a negative number is the same exact thing as subtracting like the corresponding positive number. So depending on the context and depending on you, it might be easier to think about it one way or another. So let's just see some examples. All right, if I give you 5 plus negative 4, that is the same exact thing as 5 minus 4. So the plus negative 4 is almost, it's unnecessary. Your book kind of shows this a different way than me. Like they kind of always seem to put it like this, and that's fine. So one nice way to visualize this is to use the number line, because then you'll see that whichever way you think about it, you're really going the same way with it. So if I give you a number line, and if it helps, just go ahead and draw yourself a little number line. Let's put 0 there, so let's put like -5 here. If you're adding -4, you're going to the left, right? You're going that way. So that's the same thing as subtracting 4. And it's very easy to see that it's 1, 2, 3, 4. Sorry, however you conceive of it, you're ending up in -9. So just when you're adding a negative quantity, that's the same thing as subtracting, and that means you go left. If you're adding a positive quantity, that means you go right. Okay, so whichever way you think about it, there's no real work to show that the answer is -9. Okay, so you can think about it like that. You can write it like that. Either way, however you get there, the answer is -9. So for now, if it helps you, either picture a number line or sketch a number line. So if it's not as simple as that, so what did you like? it's instructive to think about what you really did in your head when you did -5 minus 4. Really, in your head, you did 5 plus 4, and then you just made it negative, right? So it's like you're doing that anyways. So here's just what you're really doing. You're using their absolute values. Right, so this one's not quite as easy to just figure out, but it's the same kind of problem. If you're at -15 and you're going 23, negative, what you're going to end up at is, well, it's going to be whatever 15 plus 23 is, only negative. So that is the absolute value. Whether you know it or not, you are using the absolute value. So the absolute value of -15 is 15. Absolute value of 23 is 23. Now you do, either in your head or on paper or whatever, 15 plus 23. 15 plus 23 is 38. Pretty simple. And then, but then you think, wait a minute, but that wasn't even the problem. It was -15 plus -23. So then you just make your answer negative. Like that. So you just know that your answer is going to be negative. A negative plus a negative is always going to be negative. It's going to be more negative, in fact, right? So you're essentially using addition of the positive versions of the numbers. It's just that you're getting a negative number. Same deal to add numbers with different sides. So if you have a positive number plus a negative number, or vice versa, you're doing a little bit kind of a different procedure. But again, you're kind of using the absolute values whether you know it or not. So -28 plus 17. So first, before you even think of what the answer is, think about if the answer is going to be negative or positive. Okay, you thought about it. It's going to be negative because it's the -28 has more negative stuff than the 17 does. But what the answer is going to be is essentially, to do the answer, you're going to do 28 minus 17, even though that's not really the problem. Okay, if you're already like ahead of me and you're like, well, it's -11, think about how you did that. What you really did is you did 28 minus 17 is 11, but then you flipped that to being negative because you knew that it had to be negative because 28, the negative number had the greater absolute value. It was farther from 0. Okay, so take the two absolute values. Take 28 and 17, because it's just easy to deal with positive numbers. Subtract them. Do 28 minus 17. So subtract the smaller one from the bigger one. So what you're really figuring out is how far apart are these numbers. And that's what subtraction is, right? Literally the difference. What is the difference between 28 and 17? 11. And then you look back at the original problem and say, okay, but which one is it? Is it 11 or -11? And in this case, since the negative number has higher absolute value, it's farther away from 0, then that means your answer at the end of the day is negative. Okay, so maybe that's kind of a roundabout way of doing it, and if you had a way that you kind of thought about it before, and my way seems confusing, as long as you're getting it right, it's fine. You do have to kind of show me your work and just show me how you got to where you got, right? Because you're not just a calculator. You have to kind of reason it out for me. But really, no matter what you do, you're kind of doing the same thing, right? Okay, vocabulary. Evaluate is just really another word for find. So if I say, evaluate 23 times 7, I just mean what's 23 times 7? Find that number. It's just, I don't know, it's just a fancier word. So find the numerical value of the expression -13 plus 37 minus 28. I just mean compute that, or find it, or just do it. Do the math problem, right? So maybe you remember order of operations. We'll get there. There's that PEMDAS thing. But all you need to know for right now is that if you're adding and subtracting more than 2 things, 3, 4, 5, 10 things, you just go left to right. Now, if you didn't go left to right, you'd find the same answer, but it would be confusing and easy to screw up. So general rule is you just go left to right. And so this one problem kind of turns into several mini problems. Okay, so negative 13 plus 37. Kind of think about it before you even do it. So negative 13 plus 37 is going to be positive because 37 has the greater absolute value. So really what you're doing is you're doing 37 minus 13. 37 minus 13 is 24. And then again, is it positive 24, negative 24? It's positive because 37 is farther away from 0 than negative 13 was. So you've essentially collapsed that into one thing, and now you just have 24 minus 28. That's what we mean by go left or right. Just do the operation and then condense it. 24 minus 28, once again, you probably know that that's negative 4. However you're doing that, but it's good to picture the number line, because if you think 24, then you take away 28, well, you pass 0 and then you go 4 more, right? So that's just another way of saying, okay, it's 28 minus 24, which is 4, except you know that it's negative 4 because the 28 has more absolute value. Okay, so that's adding and subtracting. As we get closer to the exam, I'll make it more clear. I'll be very specific on what exactly work I expect you to show here, because there's not a ton of work to show, right? You don't have to write me an essay. You basically just have to show me one step of kind of how you did it, just to say I didn't just plug it into some calculator that I have hidden off screen. Okay. So multiply. And you know how to multiply two positive numbers. They're called times tables, and it's called, sometimes you have to do multiplication with long multiplication or whatever. So what we're going to concern ourselves with now is what if one of them is negative, or what if both of them are negative? So I'm just going to reason out for you why these rules are the way they are, because once you know the rules, there's nothing to it. So here's what's up with multiplying by a negative number. Here's what 4 times 3 means. Multiplication is called iterated addition. It means you add 4 to itself a total. There's a total of 3 factors, I guess, of 4, summands technically. So 4 times 3, you don't really think about it like this, but 4 times 3 means 4 plus 4 plus 4. Okay, and we know 4 times 3 is 12. So now think about that same logic, but do negative 4 times 3. So when we talk about doing these kind of operations on negative numbers, we just follow the logic of what happens when we do them with positive numbers. Negative 4 times 3 should be negative 4 plus negative 4 plus negative 4, right? So negative 4 minus 4 minus 4 is negative 12. And that's good enough, right? It follows logically, and it turns out it just works. There's nothing wrong with doing it that way. So negative 4 times 3 is just negative whatever 4 times 3 is. So it's not like you have to reinvent the wheel. You know 4 times 3 is 12. So negative 4 times 3 is negative 12. So you don't need to do that certainly every time, right? In fact, don't. Just multiply it and then just know the following rule. The product of two numbers with different signs is always going to be negative. So whether it's a negative times a positive or a positive times a negative doesn't matter at all. It's negative. Okay, and then you know that a positive times a positive is positive. So now let's just reason out what's up with multiplying two negatives. So I'm just going to throw something on the screen it's going to be a couple things, and we're going to look at the pattern. Okay, so we just established that negative 4 times 3 is negative 12. By that same logic, negative 4 times 2 is negative 8. Negative 4 times 1 should be negative 4. Obviously, anything times 1 is itself. And anything times 0 is 0. Hopefully you knew that, right? So negative 4 times 0 is 0. So if you just look at the numbers on the right here, negative 12, negative 8, negative 4, 0, just out of context, you would think, okay, the next number in that pattern better be 4, then 8, then 12. Right? So if you just kind of keep going here, 3, 2, 1, 0, negative 1, it should just be right. right? So if you go 3, 2, 1, 0, negative 1, it should follow that negative 4 times negative 1 is just 4. And then negative 4 times negative 2 is positive 8, and so on. So like before, you just follow the pattern, and you just say, okay, if this works, well, then this should work. And it does. It does. So that's why we say that a negative times a negative is a positive. You probably knew that, but it's my job to kind of tell you why, right? Okay, always. And then again, it's just as easy to do, negative 5 times negative 12 as it is to do 5 times 12. If you know that 5 times 12 is 60, then you know the negative 5 times negative 12 is also 60. So if we have more than one factor, more than one thing we're multiplying together, same exact rule. You just go left to right. The parentheses might seem a little bit overkill here. It wouldn't necessarily be wrong to leave them out, but I always err on the side of too many parentheses. So that's my general rule. Oftentimes, if you leave off the parentheses, it's technically wrong. It's not here, but oftentimes. It's going to be almost never that if you put too many parentheses and you didn't need them, that it would be wrong. So always be cautious, because you can lose a point if you don't put parentheses sometimes. So when we have a bunch of stuff we're multiplying together that's not all just positive, maybe get in the habit of using parentheses if you even slightly suspect that you should. Okay, so once again, you just go from left to right. So first you just do negative 6 times 4. And you think, okay, I know that 6 times 4 is 24, and I know that then it's just going to be negative because it's actually negative 6 times 4. Boom. All right, and then I have a negative 24 times a negative 3. I know that 24 times 3 is 72, and it's a negative 24 times a negative 3, so that means it's still 72, right? Still positive 72. Okay, that's that. Pretty soon we do get order of operations where we have to do all this stuff combined. But for right now, we're not there yet. So just when you see something with more than one operation, it'll be the same kind of operation. So you just literally, like I said, go from left to right. Okay, dividing may be a little bit trickier, but all I want to establish is that all the rules we just came up with for multiplying, it's the same exact thing with dividing, because multiplication and division are inverses of each other, which means that they're kind of the same thing. So dividing is the same thing as multiplying by the reciprocal, which I'll define in a second, but I think you probably remember that. So here's just some lingo. When we divide two numbers, the dividend is the thing we're dividing by the divisor. So if I did 24 divided by 7, 24 would be the dividend, 7 would be the divisor, that the thing we're dividing by, and then the result is called the quotient. And you know that, right? Like it's a sum, a difference, a product, and a quotient. Okay, so it's very easy to forget which one's the dividend and which one's the divisor. I'll probably do it. All right, so like that. So in that problem, 32 is the dividend, 8 is the divisor, and 4 is the quotient. We don't use the little division-y symbol as much anymore either. So it's not wrong to use, but we get away from it the farther we get in mathematics, and just it's not, I don't know, fashionable. So usually we just use the bar and put it over it rather than write, you know what I'm talking about, 38 divided by 4 or 8. All right, so the way we're going to conceive of this, and if this is new and not how it was described to you before, that's fine. Just bear with me. We use the idea of a multiplicative inverse, which sounds fancy, but it's not. I'll define it right now. All right, for any number a, except 0, there's some other number 1 over a, and that number 1 over a is called the multiplicative inverse or reciprocal of a. So if a is 5, then the reciprocal of 5 is 1/5.
See, not as fancy as you think. You just flip it over. So I'll probably use the word reciprocal because it's shorter. So here's the property of a multiplicative inverse. A times 1 over A is 1. And you probably knew that. 5 times 1/5 is 1. Negative 10 times negative 1/10 is 1. So even negative numbers have this, right? So you just flip it over. All right, so there's that division symbol that we don't really use anymore. But now, so the only reason I defined it like this is because now we don't need new rules. We can just use our same rules for multiplication. In other words, a positive divided by a negative is negative. A negative divided by a negative is positive. So everything's exactly the same. Right, so instead of writing A divided by B, we can just write A over B, and then we can kind of redefine that as A times the reciprocal of B. Now, for your purposes, the things you're doing the exact same process when you divide, okay? So whichever way you conceive of it. It's just this way, it just works because you can see that it's the same as multiplication. Okay, so let's do it. And again, I use the division symbol just because I want you to immediately convert it to thinking about it as negative 144 over 6. Because then it's almost like you're not even dividing. Then it's like you're simplifying a fraction. And we actually already know how to do that. So right away, think about what the quotient's going to be. It's going to be negative, right? Like what sign it's going to be, because it's a negative divided by a positive, and that's the same thing as it is with multiplication. So now, we don't really need to do like long division here. I'd rather you just thought about this as simplifying a fraction. We know how to do long division, but you don't really have to. So let's simplify this fraction. Think about some factors of 144. So you might know that 144 is 12 times 12. Or if you play around in your calculator a little bit, you can discover that. So if 144 has a factor of 12, that means it has to have a factor of 6, because 12 is a factor of 6. So if you factor 6 out of 144, then you'll actually be able to cancel that with the 6 in the denominator. So by a little bit of just thinking or messing around with a calculator or whatever, we figured out that 144 is 24 times 6. And negative 144 is negative 24 times 6. So now we can just go slash slash. See what I mean? We didn't have to do any long division. You just divide the numerator and the denominator by 6, and what are you left over with? Negative 24. Well, it's again very easy to check with the calculator, obviously, except you're not allowed to use a calculator on this first exam. So it's purely a check. You're not allowed to check it with your calculator in the first exam either, but for now, it's easy to check. Same kind of thing, and I'll say a lot of times, if this is easy for you, just either pause the video or just go ahead of me. You know what I mean? If you go ahead of me and we get the same answer, then you'll know that you're kind of good for now. And you can just keep up with the homework, and there's no reason to sit here and watch me do it if you think that you know how to do it, right? I'm not the one who's being tested here. You are. Okay, so to do 120 divided by negative 6, first rewrite it as 120 over 66, or rather negative 120 over negative 66. But it's always good to think about beforehand the sign of the quotient. Is it going to be positive or negative? And then just do what we did before, just look for common factors. So you can either look for common factors, or you can just absolutely just prime factorize, sure, both numbers. If you want to be a little more strategic, you can say, okay, well, 66 is weird because it's 6 times 11, and 11's prime. So 120 definitely has a factor of 6. In fact, 120 is 6 times 20. So if we factor 6 out of top and bottom, you get that. So, and in fact, again, I factored a negative 6 out. Although if you could also just kind of cancel the negative sign right away, because what you're basically doing is dividing by negative 1. So that gives you -6 times 20 over -6 times 11. Then you just divide numerator and denominator by -6. And you're done. It's 20 over 11. And then remember, we don't want that as a mixed number. And we don't want it as a decimal. In fact, that would be a very messy repeating decimal. So that's it. It might seem like that's like still needs to be simplified. It doesn't. In fact, if you wrote it as a mixed number, I would actually mark it wrong because we don't use those anymore, remember? So if this looks weird to you, just get used to it. It's fine. Improper fractions are now proper. Times change. Okay, let's do a story problem. Everyone's favorite. You had $3.99 in your checking account. You then paid your $69 phone bill, your $78 electric bill. You deposited your $8.39 paycheck and paid your $7.39 rent. What is your balance now? So, you know, this is just interpretation, and after that, it's just an addition and subtraction problem, right? There's no multiplication in here. So you started with $3.99. Anything you paid is subtraction. So it's going to be -69 minus 78 plus 839 minus 739. Right? So it's just, you can think about it as adding a bunch of numbers and some of them are negative. We're just adding and subtracting, but either way, we're just going to go left to right. Like that. So you should be able to do that. I'm not going to show you the work because you should be able to do it. And, you know, I want you to be doing it without a calculator. So whichever method works best for you. You may need to actually write down, you know, $3.99 with a little -69 under it and do it like that. But you should go from left to right, even though you could do it other ways. In the future, that's going to get more confusing. So just get in that habit. So crunch all those numbers. Like I said, try to get the answer, stop the video, and then come back. Okay, you're back. You should get 352. And then just a note on tests and stuff, I'm always going to say include units where applicable. And I am going to take a point off if you don't. So here, it's the easiest thing in the world just to write a little $sign. The units here are dollars, right? You don't have to write out the word dollars. Just put a $sign next to the answer. So if that seems cold, it's just like I really want you to remember what you're doing when you do an application, because that's actually what this is all about. That's the only reason we learn math, is so we can apply it to mostly money, right? So it's important. Okay, we will see you next time.